first one you wanted to go over was question 15. I'll talk you through the questions, I won't tell you all the answers, so that way you can have a go at doing them yourself, but I will at the end of the video talk you through the answers as well, and if you need a bit of extra help, anything clarified, you can just ask. Okay, so first question you wanted to look at was question 15, part B and C. So 15, part B, we've got 4 coins tossed, and we want to know the outcomes all the same. That means head, 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 or tail, 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 tail. So the chances of getting 4 heads, well, that's a half times a half times a half times a half. It's the same for 4 tails. Work each of those out and add them up. Then part C, the first tail occurs on the 3rd throw. So that means that the first 2 must have been heads, and we don't care about the 4th one. It could be a head or a tail. So it's basically asking you what's the chance of getting head, head, tail. 1/2 times 1/2 times 1/2. Okay. Next question was question 18, parts B and C. Oops. So you've got part A, which means you've got your distribution for X. Then it's asking you to write down a distribution for Y in table form. So we've got the numbers 1 to 5, and 4 spins of the spinner, and the number of spins it takes to get an odd number, and in table form. So this is the sort of table it's looking for. You've got what are the possible outcomes for Y? Well, you could get it on your first spin, your second spin, your third spin, or your fourth spin. And what's the probability of getting each of those? So, because there's 3 odd numbers out of 5, the chance of getting it on your first spin is 3/5. Now the chances of getting it on your second spin, it's not just 3/5 again, because you had to get an even number first. So it's 2/5 times 3/5. Then it's 2/5 times 2/5 times 3/5, even, even, odd, and similar for part 4. Okay, and then you just stop because they say they only spin it 4 times. Let's go back to the questions. Then part C, probability Y is greater than 2. Well, once you've filled in your table, you just look up the probability that it's 3 or 4, add them up, and there's your answer. Right, then was question 20. So question 20. Now, this is something you could solve by maths I've taught you, but there's an easier way. We didn't get around to it in class. So it's using the tables which are in the back of this textbook and are also provided in the formula book when you do the exam. It's because they're asking stuff in such a specific way, it's easier to do that. You could use the list version to have a look at all the different probabilities from 1 up to 40 using binomial, but it's a long and arduous process which you don't really want to do. So what we've got instead is we have got binomial with 40 observations. We think the probability is 0.3, but we're doing a 2-tail test to find out if it is or not. So 2.5% significance level, which means it's going to be a 1.25 significance level at the bottom, a 1.25 significance level at the top. Now what that looks like. So here you've got here's all the different number of events that could happen from 0 all the way up to 40. And the probability is going up here. Now, because it's 0.3, you're very unlikely to get all these ones up here. So this is why it's not sort of symmetrical. If 0.5, then it would be symmetrical. But we're looking for, well, if this area is 1.25 and this area is 1.25, what's the values here that are going to make this area 1.25 and this area 1.25? And the way you do that is looking up in the tables in the back of your book. Okay. Tables go through a lot of different things, but they've got specific n values. Go back a couple, there's 25, 12, 5, 6, 7. So we've got all these different n values. What we're interested in, because of the question, is n equals 40. We're interested in a probability of 0.3, because again, that's given in the question. And then we're looking at answers around the 1.25% mark. So our answers around the 1.25% mark. You can see here that this is 0.0086. That is 0.86%, and this is 2.38%. So this is too small, this is too big. So as close as possible, we're going to say that the boundary is somewhere between 5 and 6. And so that means that if you get 5 or less, you're within that 1.25%. So between 0 and 5 is successful for that. And then because these keep adding up and adding up and adding up, and looking back at this diagram, 1.25 at the top end means that 98.75 is on the bottom end. And so we're looking for one which is around about 98.75%. So here we go, 18. So 98.75 is not quite there, but you can see that if you get 18, so you're within that 98.75 lower bound, but you get 19 or more, then you're above it. So 0 to 5, and also you've got your 19 and above there. Okay, they're the sort of the safe areas. And then if we look back at the question, it's asking the critical region. So the critical region is asking, well, where is it failing this? And it's failing this either between 0 and 5 or between 19 and 40. And then state the probability of incorrectly rejecting the null hypothesis. Well, those values we looked at were not exact on there. We just sort of went to the closest ones. So if you take those exact values and just add them together, you should get the exact chances of getting it wrong, which we initially indicated we wanted to be around 2.5%. It'll be close to that, but not exactly that. That's a tricky one. You're probably going to have a look at those tables. You can have a look back at section 7.2 in the book and see if you can figure that one out, or you can just ask me for a bit more help. Question 22. So, Driti grows tomatoes over a period of time. She has found that probably 0.3 of having a ripe tomato having a diameter greater than 4 centimeters. Testing new fertilizer increases, so that here we go, one tail test, because it increases, so it's bigger than only. The size of tomatoes, she takes a sample of 40 tomatoes that have been treated using new fertilizer. Write down suitable hypothesis. Okay, you could do that one, that's great. And then using the 5% significance level, find the critical region for a test. Okay, so 5% significance level. Because again, it's asking for the critical region, and it's not asking for should we accept or reject based on some information. We're looking for, we're going to be looking in the tables again. So if we look in the tables, so again, we're looking at 40, and we're looking at 0.3, and we're looking at 5% significance. Okay, so 40, 0.3. Now 5% significance, because it was greater than, we're looking for up to 95%. So if we see here, this is 93, this is 96, so 16 is not enough, 17 is, so we're going to be looking bigger than 17, which is 18 all the way up to 40. Okay, right, so let's have a look at some answers for these, how they're written out properly. And pause it here if you want to have a go at some yourself, but other than that, I'll talk you through some answers now. So, question 15 was the first one. So, question 15. So, that's an eighth, that's an eighth. That is the calculations explained. Half times a half times a half times a half twice added together makes that, and the half times a half times a half makes an eighth as well. Question 18. So I disagree with this one, because the word in the question, it said you do it 4 times, and you make a note of when it could be odd. What if it was even every single time? So I agree with this, I agree with this, I agree with this. But if you follow the process through, then what you get for the last one is this. What they have done is they've just taken these 3 away from 1. Now, I don't like that because I looked back at the word in the question. There's nothing in there that says you stop at that point, whether you call it an odd number, even if it's not. There is a chance that something else happens. It takes 5 or 6 or 7 tries. So I disagree with that number there. I would get 0.0384. But the process they use is pretty much the same. Then their answer part C greater than 2. We'll just add in these 2 up, gets you 0.16. If you add my 2 up, you're going to get something slightly different, so I will get a slightly different answer, but that's that one. Then question 20. So like I said, between 0 and 5 on the low end, and between 19 and 40 on the high end, just looking over those different critical regions. And then if you actually add up the values when you look at 5 in the table and you look at 19 in the table and see what they actually are, add those up, you get 0.0234, which is 2.34%, which is as close as we could get to the 2.5%. And then question 22. So, like we said, if we stated our hypothesis, we then looked at the binomial tables, looked at 40, 0.3, had a look where it exceeded 5%, you got up to 17, and so 17 or lower was like the safe region, and that means that 18 all up to 40 is our critical region. If you got anywhere from 18 up to 40, then you would be rejecting your null hypothesis and you'd be accepting your alternate hypothesis. And then when you look at the actual percentages in the table, because it's not exactly 5%, it's actually 3.2%. Okay, so hopefully that was helpful. If there's anything you want more help with, let me know, and I'll do my best to get back to you. Thanks.